This program contains graphic reenactments of accidents and injuries that some viewers may find disturbing. %80 of all confined space fatalities are a result of hazardous atmospheres. Many of these fatalities occur because gas detectors were not used to test the atmosphere. Or if used, hazards were missed or underestimated. However, if you understand confined space atmospheres, conduct risk assessment, and follow correct testing procedures, accidents can be avoided. This program covers atmosphere testing, oxygen levels, flammability and toxicity, lower explosive limits, workplace exposure limits, common testing problems, and testing procedures. Before entering a confined space, the atmosphere should be tested for oxygen levels, flammability, and toxicity, and any other gas, dust and vapor identified through the risk assessment process. You cannot determine if the air is toxic by smelling it, as many gases are colorless, odorless, and tasteless. Nor can you tell if there is enough oxygen or if it is flammable by using your senses. Risk assessment determines the likely atmospheric hazards and the most appropriate detection devices to use, such as single gas monitors or multi-gas monitors that can measure oxygen levels, flammability, and 2 or more toxic gases simultaneously. Any atmospheric testing equipment used must be properly calibrated and maintained. Before entering a confined space, you must test for oxygen content. Air normally contains 21% oxygen. A safe working level for oxygen is between 19.5% and 23.5%. However, it should be noted that different organizations set their own local standards and arrangements for oxygen levels at which no work will commence. There are substantial risks if the concentration of oxygen in the atmosphere varies significantly from normal. If the oxygen level drops below 19.5%, you will start to tire easily, and your judgment and coordination become poor. At 16%, you'll find it difficult to breathe, and your heartbeat races. At 12%, you breathe very fast and deep. You experience headaches, and your lips begin turning blue. At 10%, you're nauseous and vomiting and slipping into unconsciousness. If the level of oxygen is 8%, you have only about a 4-minute window to be rescued. However, by this stage, it is especially difficult as you're probably unconscious and incapacitated. If there is only 6% oxygen level, you will drop into a coma after about 1 minute and die soon after. Above 23.5% oxygen in the air will make combustible materials such as gas, dust, clothing and hair burn faster, more intensely and hotter. For this reason, you must test for oxygen enrichment and other flammable gases, vapors or particles such as dusts. Different gases, vapors and airborne combustible dusts are potentially explosive at different concentrations in the air. The lowest concentration of a gas in the air that is needed for it to be flammable is called the LEL, or lower explosive limit. If there is a source of ignition in the confined space, an explosion will occur. The concentration of a flammable gas should be as low as possible before entry is made. Under risk assessment for a specific gas, this may be 5% LEL or less. Material safety data sheets usually provide LEL data for a particular substance. Where an LEL is not listed, refer to local standards and work safety authorities to identify it. If hot work, such as welding or cutting, is to be carried out, however, 0% LEL is required. Testing must also ascertain if the atmosphere is toxic. If a risk assessment determines that a confined space contains only one specific toxic gas, a single gas detector could be used. However, if a confined space potentially contains more than one gas, a multi-gas detector could be used. A risk assessment must be carried out to identify if there may be more than one gas present, so the most appropriate detectors and sensor range can be utilized. 4 commonly found gases in confined spaces are carbon monoxide, hydrogen sulfide, methane, and carbon dioxide. Carbon monoxide and carbon dioxide is often found around petrol or diesel-powered machinery, is odorless, and can cause dizziness, unconsciousness, and death. Hydrogen sulfide is found in sewers and other spaces where organic material decomposes. It has a rotten egg smell at low concentration, but at high concentrations it is hard to detect because it desensitizes our sense of smell. In high concentrations, it can be lethal in minutes. Methane and carbon dioxide are also produced from decaying matter and are colorless, odorless, and can displace oxygen in a confined space to the point of oxygen deficiency. Methane is also flammable. Consult with suppliers and experts to choose the appropriate gas monitor that will detect specific gases associated with a particular confined space. Gases are toxic at different concentrations. Workplace exposure limits, or WELs, refer to the permissible concentration of a gas that a worker may be exposed to on a daily basis without adverse health effects. These exposure standards are derived from various occupational health and safety organizations and industrial hygienists. Where possible, concentrations should be lowered to within acceptable limits by the most appropriate means, such as ventilation. If this cannot be achieved and sustained, personal protective equipment, respiratory protective equipment, and appropriate support is required. Workplace exposure limits are expressed in various ways. As an average concentration over an 8-hour day, a time weight average, or TWA, or as an average over a 15-minute period, a short-term exposure limit, or STEL. There can also be peak or ceiling values, which should never be exceeded during work exposure, as this level is immediately dangerous to life and health. Throughout a confined space, the concentration of a gas can vary. Gases can be heavier or lighter than air and therefore settle at different levels. A gas may settle in a nook or overhead cavity, or it may shift with the air current, both natural and those caused by the entrant. That is why it is important to test the confined space thoroughly before entering and continue monitoring during the work period. Some of the common problems that can adversely affect a reading on a gas detector include infrequent or incorrect calibration, failure to challenge test the functionality of the sensor, insufficient testing time for gas detectors to gauge the atmosphere, and cross-sensitivity from interfering gases. Gas detectors can also be affected by atmospheric pressure, increases or decreases in pressure, humidity, temperature, radio frequency interference, poor maintenance, and accidental damage. Other factors also include incorrect use or application and a lack of training or competence. We ask a lot of our gas detectors. Gas detectors need to detect very low concentrations of a gas, and often in the presence of other gases that may interfere with the measurement. A gas can be fatal when it is present, even in minute parts per million, so proper calibration of the gas detector is essential. The gas detector should be calibrated to the target gas being tested for in the particular confined space. Calibration involves applying a test gas of a known concentration and adjusting the detector sensor readout so that it shows a correct response to this reference. Be sure the test gases are used before their expiration date. Calibration will drift over time due to sensors losing their sensitivity with age or from acute exposure to corrosive gases, temperature extremes, atmospheric pressure, and humidity. A gas sensor is calibrated to give an accurate response to a specific gas, but it may also detect other gases that may be present in the confined space that it is not calibrated for, and give an inaccurate reading. The actual concentration of these other gases can be calculated using this reading and a relative response conversion chart. However, some modern gas detectors use dual sensors that utilize this cross-sensitivity effect to detect and calculate interfering gases simultaneously. Gas detectors need time to adjust to the atmosphere and for the chemical reactions to take place inside them to give an accurate reading. Testing the atmosphere for less than the response time required by the instrument could result in an underestimate of the hazard. To test a suspect atmosphere, it must either be pumped to a gas detector sensor outside the space via a tube, or the sensor must be brought to the contaminated atmosphere by lowering it inside the space. Pumping the sample out requires a bit of effort if a manual pump is used. 3 pump strokes to move the sample 1 foot up the tube, and continuous pumping thereafter for 3 minutes to ensure an undiluted sample and an accurate reading. The advantage of lowering a sensor into the confined space is that no pumps are involved, there's a faster response time, and no potential for dilution. Initial testing is done from outside. Insert the sampling probe, initially through an access hole if possible, to avoid exposure to the inside air and a potential explosion should the atmosphere be flammable. Test the atmosphere at the opening, then at different levels all the way to the bottom as different gases settle at different levels. If the oxygen level readout is below 19.5%, ventilate the space for at least 10 minutes and test again. If the atmosphere is flammable, purge with an inert gas until an acceptable LEL is achieved. Opening the cover without purging may cause a spark that could ignite a flammable gas inside. Atmosphere testing is essential to establish control measures and appropriate entry procedures. If further testing is required inside, entry must be done in accordance with confined space entry permit requirements, and a self-contained breathing apparatus must be worn. Once it is safe to enter, the atmosphere inside the confined space must then be monitored continuously in case conditions change and become hazardous. The atmosphere inside a confined space can be deceptive and must be tested to ensure that the space is safe to enter. Failure to perform thorough atmosphere testing and monitoring can result in hazards being underestimated or missed and can lead to injury or death. If a hazardous atmosphere cannot be fully controlled, appropriate respirators that offer proper protection against the specific atmospheric hazards of the space must be used. Confined space atmospheres can be dangerous, but with due diligence, training, and the right equipment, work can be undertaken safely. Your life could depend on it.